Hello students, welcome back. We went through some linear inequalities, some straightforward with just like terms only, nothing more. Some a little bit more complicated with some parentheses to break up, and some starting from the denominator. So killing off the denominators will create some parentheses and break up those parentheses, and we're going to go down to like terms. And then take those like terms together. In the end, we have the final division. If that's division by a negative number, then you have to flip. Division by positive number, then no problem. And those are for single inequalities. What if you have double inequalities like this? And these kind of problems are going to become important in calculus 2. So if you're going to go all the way over to calculus 2, say for example, if you are taking some engineering path or something, or some serious natural science, in that case, yeah, you're going to need calculus 2, and those kind of things are important. Otherwise, I don't see a tremendous importance in double inequalities. Nonetheless, let's talk about those. Let's put some space in between. And okay, alright. Step 1. Denominator. Denominator is 2, so kill it off. Multiply 2 to each term. What do you get? Multiply 2 times negative 1, so negative 2. And multiplying by 2, the denominator is gone. Multiply by 2, so we get this. All good? Alright. Parentheses, no parentheses, just like terms. Alright. 5x is only here, and that's the only x term. And constants are like terms, so you have to flip it over. But how to flip it over? There are two inequalities there. What you do is subtract 3 from each, from all three. Basically, you are doing this. Minus 3 from here, minus 3 from here, and minus 3 from here. So negative 2, this looks almost like 5. Negative 2 minus 3, so negative 5. Positive 3 minus 3, that will cancel. 8 minus 3. So if you do that, you're going to get negative 5, negative 5x, and 18 minus 3 is 15. That's what you're going to get. What did I do? I flipped this 3 to the other side, z in plural. Subtract, subtract, and subtract. Okay, alright. Now, the problem is this one. So I have to divide away. How do I divide away? Divide away by negative 5. Divide negative 5 from negative 5, we have 1 x, and divide negative 5 from 15. That's what you're going to get. I divided by negative number, so I have to flip the direction of the inequality, and this is okay, but not the best form actually for double inequality. I'd much prefer to have it in a standard form, smaller numbers to the left, larger numbers to the right. Negative 3 x 1 like this. That's much better. And of course you can readily translate it into an interval notation too. Negative 3, bracket, negative 3, and then positive 1. Like this. What do I have in my answer key? Solution set is bracket. what am I doing here in my answer key here? Yeah, it should be bracket. Sorry about the stupid typo. It's not typo, stupid mistake. It'll be corrected. So how do you deal with the double inequality? Same as before. Step 1, denominator. Step 2, parentheses. Step 3, like terms. Here, we don't really have to worry about parentheses, luckily. So denominator and then like terms. When you go ahead with like terms, substituting this, subtracting this 3 away, you have to do it in all 3 sides. Subtract 3 from the middle, that'll kill it off. Subtract 3, then we get -5. Subtract 3, we get positive 15. Make sure you do all 3 subtractions. Ready for one more? Okay, alright. Another problem like this. And then this time let's increase the font a little bit. Okay, how about this? Step 1, denominator. How do I kill off all those denominators? What's the LCD? The least common denominator is 12. 3 times 4 is 12. So multiplying 12 to each, this is what you're going to get. 12 times that, 12 times this, and 12 times that, and putting some space in between would have helped. Okay, alright, let's go ahead with the simplification. Do not multiply, divide first. The key is to kill off the denominator. So -4 and then 3 times 3 minus 7x and then 24. Alright. Okay, now break up the parentheses. 84, 9 minus 21x, 24. All good? Okay, step 1, denominator. Step 2, parentheses. Step 3, like term. And like terms, well, let's see, there's only one x term here, so it stays here. How about the others? Well, I have to move this 9 to the other side, z in plural. So I have to do the subtraction. Subtract 9 from 84. Subtract 9 from here to remove. Subtract 9 from 24. So we get -13 after subtraction, -21x, and we get 15. Did I do this right? -4 minus 9 is -13, and then 24 minus 9 is 15. Yes, all computations are correct. Alright, here divide each by -21 and you're gonna get the answer. -13 divided by -21, so 13 over 21, and dividing by negative numbers, so I have to change the direction of the inequality, right? And then 15 divided by 21, but that should be negative. Let's see, can we simplify this thing a little bit further? I think we can. Let's see, 13 over 21, alright. 15 over 21, let's see, divide by 3, so 5, and then divide by 3, 7. We're almost there. Negative 5/7 is the smallest, so it comes to the left. And then x, and then 13 21st. That completes the problem. If you want inequality expression. Now if you want an interval expression, one more step. Bracket minus 5/7. Oh, excuse me, I thought I did bracket. 5/7, and then comma 13 21st, and here we have parentheses. Let's see, that completed the problem. What did I do here in my answer key? Yes, it's the same thing, exactly the same steps. That's how you do double inequality problems. How often do I write double inequality problems? Frankly, quite often, as a matter of fact. I already said these double inequality problems do not really appear in real sense until calculus 2, but it does include some interesting techniques, and also instead of just linear inequalities, which you had been going through from elementary algebra, if I'm to write something new, then double inequality is way to go. Absolute value inequality is another thing, but that's something we're going to talk about in section 4. So either double inequality or absolute value inequality would be something to think about if you're doing an exam preparation. So if you're going to do all kind of review for basic understanding, then everything is important. Nearly everything is important. I mean, you cannot really throw away anything here. It's just college algebra. Everything is true for the next sequence courses. But if you want exam preparation, then there are some things that are more important than the others. Complex division stands out. Double inequalities are moderately important here. As for radical equations, that's X factor. It's important, yes, but everybody will struggle there too. So that's the kind of thing that you study after getting comfortably within C range and B range. And then, okay, now let's start some A problems. That's where you start. We still have one more to go, absolute value equations and inequalities. We're going to discuss those in a separate videos, or maybe two.